Hi everyone. Next one is Gauss Law. So what is Gauss Law? What is the statement of Gauss Law? The electric flux passing through any closed surface is equal to charge enclosed by that surface. Electric flux passing through any closed surface is equal to charge enclosed by that surface. So consider any object of irregular shape. Consider any object of irregular shape as shown in figure. So this is an irregular closed surface. The electric flux passing through closed surface is equal to charge enclosed by that surface. That is the statement of the Gauss law. The total charge the total charge enclosed by that irregular closed surface is Q coulombs. The total charge enclosed by the closed irregular surface is Q coulombs. It may be in any form of distribution. It may be in any form of distribution, as the total flux has to pass through that surface is psi. That is, psi is equal to Q. Consider any object of irregular shape as shown in the figure. This is the irregular closed object. The total charge enclosed by that irregular closed surface is Q coulombs. It may be in any form of distribution. The total flux has to pass through the surface, pass through that closed surface is psi. Consider a small differential length, and this is a consider a small differential surface. So this is a differential surface ds. Consider a small differential surface ds at point P. At that point P, the direction of the electric flux density is normal to the surface. At that point P, the direction of electric flux density is normal to the surface. Consider a small differential surface ds at point P. As the surface is irregular, the direction of electric flux density as well as its magnitude is going to change from point to point on the surface. The surface ds under considerations can be represented in the vector form. The vector form of the differential vector surface area is given by ds bar is equal ds into an bar, where an bar is the unit vector in the direction normal to the surface sheet, and this is the differential surface sheet ds at that point P. At that point P, an bar is the unit vector in the direction normal to the surface. Normal means perpendicular to the surface. This is the surface. At that point P, an bar is the unit vector in the direction normal to surface sheet. So that is the vector form of the differential surface area. The electric flux density at point P and its direction is such that it makes an angle theta with normal direction at point P. At point P, the electric flux density and its direction is such that it's make an angle theta, some angle, with normal direction at point P. The electric flux d psi passing through the surface ds is the product of the component of d bar in the direction normal to the surface at that point P. So mathematically, this can be represented by the electric flux passing through the surface ds is product of the component of d bar in the direction normal to the surface. So that can be represented in mathematically d psi is equal dn into ds, where d suffix n is the component of the electric flux density or magnitude of the electric flux density. So from the figure, the component dn is equal magnitude of d bar cos theta. Substitute this dn value into above expression, we get the flux d psi is equal magnitude of d bar cos theta into ds. So using dot product between two vectors, a bar dot b bar is equal ab cos theta. So using the derivations, magnitude of d bar cos theta ds is represented as d bar dot ds bar. D bar dot ds bar. So using dot product, what is the value of d bar dot ds bar? Capital D into ds into cos theta. So therefore, the flux d psi is equal d bar dot ds bar. So this is the flux. This is the flux passing through the incremental surface. So therefore, the total flux psi is equal surface integral of closed surface integral of d bar dot ds bar. So this is the mathematical equation of the Gauss law. What is the statement of the Gauss law? The total flux passing through the surface is equal to charge enclosed by that surface. That is psi is equal to q. Psi is equal to q. So this is the integral form of the Maxwell equation. First integral form of the Maxwell equation. Psi is equal, q is equal, closed surface integral of d bar dot ds bar is the one of the Maxwell equation in electrostatic. That is first Maxwell equation in electrostatic. Q is equal closed surface integral of d bar dot ds bar. Once again, the statement of the Gauss law. The flux passing through any closed surface is equal to charge enclosed by that surface. That is, psi is equal to q. Next one is special Gaussian surface. The surface over which is Gauss law is applied. The surface over which is Gauss law is applied is called as Gaussian surface. Obviously, such a surface is a closed surface and it has to satisfy the following conditions. So that are, first condition, the surface may be irregular but should be sufficiently large so as to enclose the entire charge. And second one is the surface must be closed. And third property is at each point of the surface, the electric flux density is either normal to the surface or parallel to the surface. Parallel means tangential. The electric flux density at any point on the surface is either normal to the surface or tangential to the surface. Normal means perpendicular to the surface. Tangential means parallel to the surface. And fourth condition is the electric flux density is constant over the surface at which d bar is normal. So these are the properties of special Gaussian surface. To determine the electric flux density on the surface, we must consider the Gaussian surface. So the shape of the Gaussian surface must be closed. The shape of the Gaussian surface must be closed. Next, coming to proof of Gauss law. Consider a spherical coordinate system. A point charge q is located at the origin. Point charge q is located at the origin. On this sphere, consider differential surface ds. Point P. At point P, the direction of the electric flux density is normal to the surface. At that point, the direction of the at that point a r bar is the unit vector in the direction normal to the surface at that point. So, and radius of this sphere is a meters. Radius of the sphere is r is equal to a. So determine electric flux density and apply Gauss law. Consider a spherical charge consider a spherical around a charge center at origin. To determine electric flux density and apply the Gauss law, consider a spherical around the charge center as origin. The spherical surface is a Gaussian surface. The spherical surface is a Gaussian surface. It satisfies the required conditions. What are that one? The electric flux density is always normal, is always radial direction, or the direction of the electric flux density is always moving radially outward direction or perpendicular to the elementary surface sheet. So what is the radius of the sphere A? R is equal to A. The direction of the electric flux density is along AR bar, which is normal to ds. In spherical coordinate system, the differential surface ds is equal r square sine theta d theta d pi. In spherical coordinate system, the differential surface ds is equal ds bar is equal r square sine theta d theta d pi AR bar. Since r is equal to a, ds bar is equal a square sine theta d pi into ar bar, where ar bar is the unit vector in the direction normal to differential surface. We know that the electric flux density at point P due to the point charge Q is located at the origin is given by d bar is equal q by 4 pi r square into ar bar, where ar bar is the unit vector in the direction normal to the surface. Since r is equal to a, the electric flux density d bar is equal q by 4 pi a square into ar bar. Now determine dot product of d bar and ds bar, dot product of electric flux density and differential surface area. D bar dot ds bar is equal what is capital D bar? Q by 4 pi a square into r bar dot what is ds bar? A square sine theta d pi into r bar. Dot product of same unit vectors is unity. Now here ar bar dot ar bar is 1. So that is equal d bar dot ds bar is equal q by 4 pi a square sine theta d pi. Numerator and denominator a square is cancelled and the remaining expression q by 4 pi sine theta d pi. So what is the LHS term? D bar dot ds bar. What is the d bar dot ds bar? That is the d psi. D psi is the total flux passing through the surface is equal to the product of the electric flux density and differential surface area. So d bar dot ds bar is d psi. So that is equal, that is the d psi value. Calculate the total flux. So take the closure surface integral on both sides. The total flux psi is equal closure surface integral of the RHS term. Surface integral of now here d theta and d pi. In spherical coordinate system, theta is varies from 0 to pi and pi is varies from 0 to 2 pi. So therefore, q by 4 pi integral theta is equal to 0 to pi sin theta d theta integral 1 integral pi is equal to 0 to 2 pi 1 into d pi. Integral sin theta is minus cos theta over 0 to pi. Integral 1 d pi is pi over 0 to 2 pi. So after applying the limits value, lower values and upper values of theta and pi, so we get psi is equal to q. Psi is equal to q. That is the proof of the Gauss law. What is the statement of the Gauss law? The electric flux passing through any closed surface is equal to charge enclosed by that surface. That is, psi is equal to q. Psi is the total flux passing through the surface is equal to total charge enclosed by that surface. That is, psi is equal to q. Hence, the Gauss law is proved or verified.